figure can be enclosed by 3 lines? Triangle. And when we get to 3 or more lines, now we can shift it into just straight segments, because that's the minimal number of straight segments that can enclose a space. So when we talk about straight segments enclosing a space, we're referring to figures that are called polygons. Okay, so polygons are coplanar figures that are formed with only straight segments. That intersect only at their endpoints. Okay, so when we look at this, the conditions that have to apply for something to be a polygon, okay, has to be coplanar. Okay, it has to be a figure, and by figure means it has to enclose a space. Okay, it can't be left open-ended. Okay, it can only use straight segments. So all the lines are line segments, no curves to it. And then finally, they intersect only at their endpoints. And they don't crisscross in the middle. Okay, so when you look at a polygon with 3 sides, okay, so if you take 3 points, A, B, and C, and you connect those 3 points with straight segments that are coplanar, they completely enclose a space, and they intersect only at their endpoints, you have the triangle. Okay. So a triangle, just again, simple definition, is a polygon with 3 sides. And now, by calling it polygon or putting that term within its definition, all the conditions that have to be met by a polygon are implied with just that word. Okay. When you name any polygon, and that includes the triangle, the way that you name it is you can just put the points in order, some consecutive order. So you can go counterclockwise or clockwise. You can start at any point. So we could name this triangle ABC. We could name it triangle ACB, so we could go either order. We could start with point B and call it BAC, or triangle BCA. Or we could start with point C and go CAB, or even CBA. So these are all the different ways that you can name it. With a triangle, you can put a triangle symbol in front. If you just put A, B, and C, that would still represent triangle. And with any polygon beyond that, again, just naming every single intersection of their sides gives you the name of that figure. Okay. The intersection of the sides are called individually, each one is a vertex, plural or combined, it's vertices. Okay, so vertices just mean the intersections or endpoints of the sides on a polygon. Okay, and as far as, let's continue to expand polygons by sides. If you took a polygon with 4 sides, okay, so again, if we took 4 points, W, X, Y, and Z, what kind of polygon would we have here? Just in general, a quadrilateral. And again, make sure if it asks you to classify a polygon by the number of sides, use quadrilateral. Don't use the more specific terms that might equate to a picture. So this kind of looks like a different type of quadrilateral, but you'd still just call it a quadrilateral, which again simply is polygon with 4 sides. Once again, we would name this W, X, Y, Z. And if you wanted, you could write the word quad to indicate it's a quadrilateral. If it were a specific figure like a square, rectangle, or parallelogram, you could include a little symbol in front as well for that. But as long as you identify the consecutive vertices, you're able to name it. And now, you can name a polygon using consecutive vertices if you look at non-consecutive vertices. So, two vertices that do not are not connected through clockwise or counterclockwise rotation. So that would be this segment and this segment. Anytime you connect non-consecutive vertices, you're creating what's called a diagonal. This quadrilateral here has 2 diagonals. If we went to some of the classification of polygons that go beyond quadrilateral, so let's say 5. A 5-sided polygon is called a pentagon. And if we were to sketch in all the diagonals of the pentagon, there would be 2 non-consecutive points for every point. And so we'd have 2 diagonals extending from each vertex. Okay, so these would be all the diagonals here. Okay, and again, you can continue this on page 14. There's a table with a list of all the different polygons based on their prefix that represents the number of sides that they have. And so make sure you check on that and become familiar with it if you're not already familiar with those polygon classifications. Okay, now, there's another way to classify polygons rather than number of sides. Okay, so if you classify by sides, see page 14 for that list. You can also classify by convexity. Okay, and this classification fits one of 2 forms, convex or concave. Okay, convex polygons are the ones that you're probably the most familiar with. Okay, so this triangle, this quadrilateral, this pentagon are all convex. Concave, there's no such thing as a concave triangle. A concave quadrilateral would look like this. If we took a concave hexagon having 6 sides, would look like this. Okay, the difference in these has to do with the location of diagonals. In a convex quadrilateral, no part of any diagonal falls outside the figure. Okay, so in a convex polygon, any diagonals that you draw will always remain in the figure's interior. Okay, for concave, again, easiest thing to remember, it's just like each figure has kind of an indentation like a cave opening. Okay, but it means that the defining characteristic is that some part of some diagonal lies in the figure's exterior. Okay, so again, if we looked at all the diagonals on these, they're never going to fall outside the figure themselves. However, if we look at the diagonals of these, here's one that falls outside. Again, a couple of them that fall outside. So when you're looking at that, once you find some part of some diagonal that falls outside, then it would be classified as concave.